Okay, let's go through exercise 5.01, the hyperbola. Hopefully this will answer some of the questions you may have had. Question 1, the diameter of a balloon varies inversely. So the hyperbola represents inverse variation, and so if I just draw over here, it means that one of the variables, in this case, let's say it's the diameter, and the thickness would be the x variable. If we were to graph those, they would form a hyperbolic shape or an inverse variation, and it's drawn like that. You can often have the other side of the hyperbola over this side, this mirror image, but in real life situations like this, it's generally when you're sketching only this positive part of the curve that you need to draw. The diameter of the balloon, we've been told we've got an 80mm balloon when the rubber is 2mm thick. So we're going to use that to form work out what the equation is. Now we can start off d for diameter equals k over x, and if you've read the notes, k is a proportionality constant, which will be the same for each question. In this question here, if we make k the subject, so we're going to go k equals d times x, and the two values that we've been given in the question were 80 and 20, so that gives us a value of k of 160. So for the rest of this question, we're going to use d equals 160 over x to answer any of the other questions. So that's question A done. Question B, find the diameter when the thickness is 0.8. So all we're doing is substituting 0.8 into that formula for part B, and if you chuck that into your calculator, you should get 200mm as the diameter. Find the thickness, so find x, correct to one decimal place when the diameter is 115. Well, when you've got an inverse equation like this, if you want to find out what x is, you could just swap the x and the d over. That's a really useful thing to know about these type of equations. You swap those over, and now you can do your substitution. So 160 over 115.3. And let's chuck that into the calculator. Uh, 1.4 to one decimal place. The last question, sketch that curve. So I sort of pointed it out here, but because it's a real situation, I mean, you obviously use a ruler if this was an assessment question, but we'll put d here as on the vertical axis, x as the independent variable, and then we're going to sketch in that hyperbolic shape. No need to sub lots of values in and graph that. You just need to be aware that that is the shape. You could then put a couple of the bits of information here. Say we had x equals 2, you could put that there and put 80. Hopefully that doesn't line up perfectly, but you get the idea that this point, showing this point, and if you wanted to, you could even show this point here. It's probably a little bit tighter up. I've got to move that across a little bit, but you get the idea. As long as you've got, when it says graph showing this information, you could just put at least one of the points on the graph somewhere. On to question 2. The more boxes a factory produces, the less it costs per box. Again, that's inverse variation. So we're going to have, in this question, the cost of the box is C, the number of boxes is N. So our equation, our inverse equation, will be C equals K over N, and we can figure K out by multiplying the C and the N given. In this case, it was 120 and $2. I'm sorry, 128. It was 256. Now K is not going to have any units. I drew even though I put a dollar sign there. So for this question, we're going to use 256 over N equals C. Find the cost per box when we for each box when we do 100 boxes. Well, we substitute N equals 100. Nice easy one there. We should get the cost being $2.56 per box. How many boxes must be produced for the cost of each box to be 50 cents? So we want the cost C to be 50 cents. Be careful there. Obviously, if we're dealing in dollars and cents, we want to put in 0.50, but 0.5 is fine. 256 over N. Swap these two over. N is equal to 256 over 0.5. and that means we'd have to produce excuse me, 512 boxes. And again, sketch this information. We're going to put C as the dependent variable and N as the independent variable, so it'll go down on the x-axis. And we sketch our inverse variation, our hyperbola, and we'll put a couple of bits of information. Let's put the 128 and the $2. So I'll put in here $128. We'll put a dot there, and we'll come over here and make this $2. As long as we've got one bit of information, we should be fine there. Okay, question 3 is probably the most important question in this set. It's being able to sketch a hyperbola based off of an equation and state the domain, range, and any intercepts. So if we have a look at this one, y equals 2 over x. If we were to sketch that on these axes here, it's going to look just like this. We're going to have asymptotes along the x and the y axis. That should be along the y-axis. Let's see if we can do a little bit better here. That should be along the x-axis. Now, why do these asymptotes exist? Well, what x values can't we have? We can't have a 0 at the bottom of a fraction. So that's why we can't have this vertical asymptote x equals 0. The graph doesn't occur there. And also, for these particular graphs, there's always going to be an asymptote at y equals 0 along the x-axis, because there's no x value that we could substitute in here to make y equal to 0. And if you think about that, we can't put 0 in there, and any then positive or negative number, we just can't generate 0, so we'll always have that asymptote across there. Now, in this course, this vertical asymptote can shift left or right. The horizontal one here will 99.9% of the time stay the same, but this one will shift depending on what we have down here in the denominator. If we have other numbers here, this will shift either left or right, and we'll have a look at that in B and C. Anyway, for this one, based off this graph here, our domain, so all our x values, we can do any x value except x equals 0. So we're going to go from negative infinity up to 0, not including 0, so we'd use the curly brackets. Smiley face, 0 to positive infinity. Now, this way of drawing the domain is particular to the hyperbola, where you've got this joining bit. This is a symbol for intersection, and it's signifying that there's an asymptote at 0. So the graph is continuous here. There's a discontinuity here, which is the asymptote, and then it goes again from 0 up to infinity. The range is going to look exactly the same because the graph is going all the way from negative infinity up to positive, but there's a break here at 0, so the range will look exactly the same. Find any y-intercepts if they exist. Well, y-intercepts occur when x equals 0, and as we stated before, we can't. If we substitute x equals 0, we'll get an error with that equation, which is the asymptote. So there are no y-intercepts. And part 3, sketch the graph. Well, we've already done that over here. So let's go to a slightly more complicated version. Well, it's not so much more complicated. It's a very similar equation, except we've got a negative sign. In that case there, any negative hyperbolas, that instead of being over in this section, the curve moves over to this section. If you compare that to the last question, this is positive. And if we come back here, this would be what would be negative. What does the 1 and the 2 do to the equation? Well, it just makes it a little bit more steeper, which, I mean, I've probably drawn this one a little bit steeper than the first one, but this one here won't grow as fast as this previous curve. And on just simple sketches like you'll do the majority of the time, it's probably not a quantity that you're going to be worried too much about. It's really, for this question, what's the significance of that negative sign? So your domain and your range for this question will be identical to A, if we go back to that one there, because the asymptotes haven't moved at all. The graph is still going from positive to negative infinity in both the x and y. Find the y-intercepts. Well, again, there's no y-intercepts because we can't let x equal. And sketch the graph. Well, we've already done that part there. Slightly more complicated, we've got a number down here in the denominator now with x. So what does that signify? Well, from part A and B, x can't equal 0, the denominator couldn't equal 0. So in this case here, we can't have x plus 1 cannot equal 0. If we shift the 1 across here, that means that x cannot equal minus 1. The significance of that is we're going to have an asymptote, instead of being along the y-axis, is going to be at x equals minus 1. It's a positive hyperbola, so that means that the hyperbola will be in this part of the curve, and it will be in this part of the curve. Notice the difference between this equation and that graph, and if I go back to A, everything's just shifted across so that that vertical asymptote, instead of being at 0 for that first part, is now at minus 1. And it's all to do with what value of x is going to make this bottom or the denominator equal to 0. The horizontal asymptote would still be along the x-axis. The domain and range now. So our domain, well, that's all our x values, so it's shifted now. It's still from negative infinity, but we're going to go up to minus 1, and then from minus 1 to positive infinity. Our range will be unchanged. So we're just going from 0, between 0 and 0 there. Find the y-intercept. Well, we can see that there is a y-intercept, and this time we can substitute what happens when we put x equals 0 into that equation. Well, we get 1 over 1. So y-intercept will be here at y equals 1. And sketch the graph. Again, just sketching the graph. No need to do a table of values on these type of questions. The main points to be looking for that you've got your asymptotes clearly evident on your graph, and any intercepts like we just did there clearly labelled either as y equals 1, or if you wanted to say, well, that's x 0, y equals 1 as well. So part D, let's start with the denominator. What number of x is going to make that 0? Well, obviously it's going to be x equals 2, so that's going to give us a vertical asymptote this time over here at 2. Just label that. It's a positive hyperbola, so we're going to have our hyperbola in the positive sections, and you'll notice because of that we're going to have a y-intercept down here somewhere. Now our domain, obviously, hopefully you got the hang of this now, it goes up to 2, and from 2 to infinity, and our range, there's that break at 0. The y-intercept, well, let's let x equal 0, and that'll give us 3 divided by minus 2, and if you like, that's 1.5. So this intercept down here will be y equals minus 1.5. On to the last one. Again, this is a negative. What makes this equal 0? Hopefully from observation you can see we're going to have an asymptote at x equals 3. So we can go graph that one in. Obviously you use a ruler if you're doing this in your book. It's a negative hyperbola, so this time we're going to be in this zone here, and this zone here. We'll never touch that asymptote, it's just terrible drawing on my part. There's a y-intercept here. That y-intercept will be where this, what value, well, if we let x equal 0, so if we substitute 0 into there, we get minus 2 over 0 minus 3, and that'll give us minus 2 over minus 3, which is positive 2/3. And the graph there again, y-intercept and the asymptote. On to question 4. Show that this is an odd function. Well, odd functions, if we substitute a negative value, it'll give us the function being negative value. So let's just test that out for this function. If we substitute negative x in there, we'd get 2 over negative x. And an equation like this, we can just take the x out, which is negative of the original function. The original function was 2 over x, so we get minus 2 over x. So therefore, that one's odd. The last question. Y equals minus 2 over x plus 1. Is it a function? How can we tell if something's a function? Well, if we were to sketch this, we might do the sketch first. So if we have a look at any vertical asymptotes, that would be at x equals minus 1. So if we go pop that in, it's a negative hyperbola, so we're going to be in this section here, and we're going to be in this section here. Now, is it a function? Well, does it obey the vertical line test? If we put a vertical line anywhere through this graph, would it cut more than once, or would it cut only once? If it only cuts once, that would be a function, so we get the big tick there. Is it either odd, even, or neither? Well, in this case here, remember, odd and even functions have symmetry. Even functions are symmetrical about the y-axis, so it's definitely not that. Odd functions have point symmetry about the origin, definitely not that. So in this case, it's neither odd or even. Is it continuous? Well, it's not continuous because it's got an asymptote, both a vertical and a horizontal. Continuous curves would have no breaks in them, or no sharp points. What is the equation of the asymptotes? Well, in this case here, the asymptotes, we've already drawn that one. There'd be also this horizontal asymptote, and the equation of that would be y equals 0. It's the x-axis. Part C, state the domain and range. We've done this a few times already. In this case, the domain from negative infinity up to minus 1, smiley face, minus 1 to infinity. And there is our range. So hopefully, if you were having problems with that first set, that has helped you out. Sorry, it's a little bit longer than I would have expected there. And yeah, I'll do another video for 5.02 soon. Good luck.